Hello, and welcome to our presentation on the effects of microgravity on vaccine development by Evian Lowe, Tegan Lin, Kate Sampson, Gabe Eisen, and myself, Matthew Alf. Today, we'll be exploring how the unique conditions of microgravity, like those experienced in space, can influence the development, stability, and effectiveness of vaccines. But before we dive in, let's take a moment to understand what microgravity actually is. Microgravity refers to the sensation of near weightlessness that occurs when objects are in freefall, such as astronauts and equipment aboard the International Space Station. This environment creates conditions that differ dramatically from what we experience on Earth, and these differences can have surprising effects on biological processes, including how vaccines behave and are produced.
Research in space has shown that microgravity has a significant impact on microbial behavior. One of the key discoveries is that bacteria often become more virulent in space. For example, Salmonella, a common cause of foodborne illness, became more potent during experiments conducted by NASA and Dr. Cheryl Nickerson's team in the early 2000s. Another example is Pseudomonas aeruginosa, which is typically harmless on Earth, but can become dangerous in space due to reduced astronaut immunity. These changes are linked to alterations in gene expression, protein folding, and microbial growth under microgravity conditions. This unique environment allows researchers to observe biological behavior that is not possible to replicate on Earth, making space a valuable setting for studying human health risks and developing effective countermeasures. Microgravity not only changes how bacteria behave, but it also allows researchers to uncover new therapeutic targets for vaccines. In space, bacteria unmask themselves, revealing traits that are normally hidden under Earth's gravity. This makes it easier for scientists to understand how diseases work and how to prevent them in the future. Dr. Cheryl Nickerson's research on Salmonella laid the foundation for space-based vaccine development in 1998. A major milestone preceding this in immune system research came with NASA's twin study, which monitored astronaut Scott Kelly and his identical twin, Mark Kelly. One focus of the study was testing immune responses to flu vaccines in microgravity. The findings showed that Scott's immune system responded appropriately, confirming that flu vaccines remained effective before, during, and after spaceflight. This was a major step forward in ensuring astronaut safety and validating space as a platform for immunology research. As the potential became clearer, space agencies around the world, including NASA and the European Space Agency, began forming partnerships with pharmaceutical companies to expand upon this research. Together, these past initiatives laid the foundation for today's advancements and demonstrated that space-based health research could directly benefit both astronauts and people on Earth.
As we continue to travel farther out into outer space and for longer periods of time, it is important to start researching more about efficient vaccines and microgravity. Due to microbes changing their physiological state and some becoming more virulent, scientists have been working on developing vaccines to help combat this and to ensure those in space still get the medical care they need. Scientists have also found that studying viruses in space can be beneficial for creating vaccines on Earth. First, let's talk about how the immune system is impacted once an astronaut is launched into space. Once launched, the harsh environment causes a strain on a human's immune system and can slow it down. Cells involved with the immune system are alerted and weakened by the gravitational shift, which can cause many of them to lose their function or become weak. Bone marrow is impacted by the gravitational change, which leads to a decrease of T cells, macrophages, and lymphocytes, thus weakening your immune system. Researchers are not sure how much these effects will change depending on how long an astronaut has been exposed to microgravity, but they have also stated that the inflammatory response is weakened as well. Due to all cells being inactive and the inflammatory response is weakened, this slows down healing processes or puts you at higher risk of infections. Next, let's talk about how vaccines are developed. Scientists use a method called the Pathfinder approach when developing vaccines. This approach begins with a set of flight experiments to identify the components of an organism in space that stimulate the virulence of a microbe. Scientists then use that information to pinpoint targets for vaccines. Because microgravity is shifting how cells and microbes function, it reveals hidden behavior that would not have been present on Earth. Scientists are finding it beneficial to study how vaccines and certain pathogens work in space as well because certain protein crystals are more visible when crystallized in space. Recent scientists from Arizona State University, Nickerson and Roy Curtis III, have sent over vaccines to the space station STS-135 to improve on vaccines for pneumonia that is still currently being studied. Scientists are continuing to send vaccines and genetically altered diseases and blood samples to space for study in hope of developing better vaccines.
As commercial spaceflight and research opportunities continue to expand, The future of vaccine development and microgravity holds incredible promise. By harnessing the unique environment of space, scientists are on the verge of revolutionizing how we understand and combat disease, both on Earth and beyond. One of the most exciting prospects is the advancement of personalized medicine and the microgravity environment. Researchers can study subtle genetic and molecular changes with exceptional clarity. This could lead to the development of vaccines tailored to individual genetic profiles, significantly improving their effectiveness across diverse populations. Microgravity also offers a powerful platform for accelerating vaccine development. By studying how viruses mutate and how the immune system responds in space, scientists can gain valuable insights that would be difficult to observe on Earth. With AI-powered analysis of space-derived data, researchers can improve predictive models of pathogen evolution, potentially identifying vaccine candidates much faster than before. As we look ahead to long-term human spaceflight, such as missions to the Moon, Mars, and beyond, ensuring astronaut health becomes a top priority. Vaccines developed in microgravity may help protect crews from novel spaceborne pathogens or changes in immunity that occur in space. Another transformative application lies in the production of vaccines themselves. Microgravity has been shown to enhance the purity and stability of biologics. This could lead to more efficient and scalable manufacturing processes, with reduced reliance on complex purification methods. Space provides a unique vantage point for studying diseases over time. In microgravity, researchers can monitor how pathogens evolve and how the immune system adapts. This kind of ongoing surveillance can inform preemptive vaccine strategies, helping to mitigate future outbreaks before they become full-scale pandemics. The momentum behind this field is being driven by unprecedented collaboration. Government space agencies, academic institutions, and private companies are all coming together. Programs like Artemis and new commercial space stations are laying the groundwork for advanced medical research in orbit. The convergence of biotechnology and space science is opening a new frontier for global healthcare. With continued investment and collaboration, vaccine development and microgravity is poised to play a vital role in both our fight against disease on Earth and our exploration of the universe. The innovations emerging from this field have the potential to save lives, protect astronauts, and redefine what's possible in medicine. That wraps up our presentation on the effects of microgravity on vaccine development. We hope it gave you a deeper understanding of how space-based research can play a critical role in advancing public health here on Earth. Thank you so much for watching, and with that, we'd love to open the floor to any questions you might have.